Hello folks, welcome back to Oxygen Not Included. Today we start with a bit of innovations. Last episode I realized that all of my auto sweepers were not really efficient, so this auto sweeper could not reach a delivery point for this glass forge. So now I want to see if I make this auto sweeper up, will it be able to deliver? So that's why I'm trying to move this glass forge upstairs and see if this auto sweeper can actually deliver sand to it, because I think the delivery spot is somewhere in the third row. So it might be this tile or it might be this tile. If it is that tile, then this auto sweeper can reach it. But if it is this tile, then we need to figure out another design where we can keep this. Another thing is we had to move this metal refinery one tile to the left. Again, the same thing, the delivery spot was somewhere over here. So hopefully it should work. So let's see. Right now I just connected it temporarily to a power supply, and if I say class 1, Steve is the current errand. Yeah, this auto sweeper cannot reach it. I think it is this spot. So let's see, where is Steve putting it? Yeah, this one. So let's figure out how we can assemble all of these. I still don't want to spend more on auto sweepers. I would prefer to not have to do this. Okay, this time it should be fully automated. So again, you can see here, this auto sweeper can obviously reach these two machines, that's fine. But now it can also reach this square or this cell of glass forge. So if I queue up molten glass forever, it should pick up all the sand and deliver it like this, and that's great. Now it can also deliver it to rock crusher, obviously, and we just moved our refined carbon production to this place. Right now we have 10 tons of refined carbon, so it's not going to refine anymore because we have simplified the automation here, where it's just checking the weight of dropped carbon. If there is dropped carbon over here, it will not refine anything unless it is below 50 kgs. So this is 50 kgs, and we have a storage for refined carbon right here. So this block, this is the new storage tile storage that ONI has added. Now this storage can be accessed from this direction by this auto sweeper and picked up by this auto sweeper to put it in our metal refinery. Now it can see, you can pick up lime from here, put it in there, pick up refined carbon, put it in there, and everything is up and ready. Now only a dupe has to come in and just do the chore or errand. Now right now it is only having 400 kilograms of oil, which is equal to one batch. I want to increase it to multiple batches. So let's say if I want to do 2 batches, I need to put in more 400 more kgs of oil in it, and this should allow refinery to run continuously with 2 cycling liquid. So one batch will be 400, next batch would be next 400. Similarly, I'm going to do glass forge, and glass forge has a similar automation using the weight plate. You can see here, if this is less than 2000, then this will activate, and the buffer gate will say, okay, run the glass forge for next 200 seconds. Same, run this for next 200 seconds, run this for next 200 seconds. And everybody here, you can see, has a lit workspace. So this is lit. So Ellie has a lit workspace, Steve has a lit workspace, and whoever is going to work on a rock crusher will also have a lit workspace. And that is the crux of our steam room automation. Now decor wise, it's not looking really pretty because we have a lot of negatives around here. So I'm just going to put some statues here and there just to improve a bit on decor. I also need to improve the decor in here, because right now you can see it's not perfect. It has a little bit of decor because of lighting and stuff, but still it's not perfect. We are just going to run glass forever because we need a lot of glass. Also, interesting thing about this thing is cooling glass is hard. Glass comes out at 1800 degrees Celsius. You can see here it's 1900 degrees Celsius molten glass, but these two tiles are made out of steel, or these two pipes are made out of steel. So that's why we are limiting glass to 1 kilogram per second. That will make sure it does not state change during cool down, and it can get cooled down instantly. As you can see, glass is coming out here at 1800 or 1900, and it is getting out here somewhere around like 200ish. So you can see here, glass that is collected here is 225 degrees Celsius, and that is pretty good. And that heat is going to get stored in these batteries on this side. We also have aqua tuner running non-stop, which is trying to chill down this area, which is pretty hot for some reason. I think it's just the heat leaking from all the other places. We also need to increase the size of this water tank. This water tank is not big enough, so certainly I need to do work on that. For now, I'm just going to deconstruct this tile so that all the excess water gets flooded down at the bottom. That's fine. We can collect this water in this tank for now. Disable auto repair, or that is the really hot water, so that's fine. Next, we need to work on our fridge. So I think I'm going to put my fridge somewhere over here, and it will have a freezer access which will be accessible by duplicants using this tile. I just put a tiny blob of petroleum, like 300 grams of it, so that way dupes can access it across one tile, and we can still have decent enough chilling. Now, what I want to do is have these copper tiles made here so that food gets flash frozen before it gets sent into the freezer. So let me figure out a design of a freezer with a fully functional kitchen. And this will be our freezer. So it is a multi-tiered freezer which has different locations for different things. So let's take a look one by one. So first of all, we have, I just need to put one more light here. I could not figure out a single light. I need to put this light slightly one tile above. Yeah, we can do that later. But right now Marie needs light, so that's why I'm putting it here. Okay, so this is the design. The design is simple. First of all, we have a shipping rail that is bringing us meat. So all the fresh meat is going to directly come here using this shipping rail. We moved our evolution chamber from here to all the way down here. So all the hatch eggs are directly going to get dropped right here in this vertical tunnel. So this will be our drop off tunnel, and everything is going to get dropped here in this corner. From this tunnel, what we can do is we can select meat and anything edible basically. Yep, so auto sweeper is going to pick up everything from here and just push it up this conveyor shipping rail. This shipping rail goes all the way up and goes here. It jumps from here to here and gets stored right over there. Now let's add some freezing to it. We'll just put a steam turbine and aqua tuner and done. So this kitchen has multiple stages. First of all, let's take a look at the storage. So this is gonna be our storage area where we are going to store all the raw food as well as processed food. Now you can see there are two access points here. These two access points are important for dupes because they should be able to access cooked food. They were able to access food from diagonals earlier, but they only fixed it. So now the only way dupes can access frozen food is through a liquid lock. And I don't want dupes to walk through the liquid lock. That's why this height is only one tile. So that's why they can just stand here, pick up the food that is here, and then go on their merry way. So right now duplicants can do that, and our auto sweepers can also do that. So this auto sweeper is able to access these two corners. So all the raw food is going to come here through shipping, including meat and all the crops, and that will be delivered to our electric grill. Electric grill is configured to cook everything that it finds. Now whatever electric grill cooks is going to get delivered to this auto sweeper or this conveyor loader. So here I'm going to say edible and barbecue. Barbecue, fried mushrooms, frost buns, gristleberries, roasted grapefruit nut, and that's pretty much it. Grapefruit preserve as well. So now shipping wise, you can see this is just going to move everything through this tile. Okay. Now this tile is accessible by this auto sweeper. So what will happen is this auto sweeper can pick up whatever barbecue and stuff that is here and put it in the gas range if we want to cook something interesting, something secondary. Where let's say if you wanted to cook surf and turf, where is surf and turf? Here. You need barbecue as well as cooked seafood. So you can cook seafood and barbecue here, put it in this conveyor loader, push it here. This auto sweeper can take it from here and put it back in the gas range. Now gas range is going to cook everything. Once it is cooked everything, it is going to get picked up by this conveyor loader again, and this conveyor loader can put it here. So here I can say edible wise, I haven't cooked all of those things, but once I cook them, I can select them here. So this conveyor loader goes here, where here is the bridge that bridges every food that is loaded in this conveyor loader, that is a secondary conveyor loader, to this loop. Now this loop, what it does is it just chills the food constantly by going in the loop, up and down and up and down and up and down. And there is a thermosensor here. I can say if the food's temperature, let's say, is below -25, right? So that is the food I want to have. If the temperature is below -25, it will open up this conveyor shutoff, and this conveyor shutoff is going to push the food up here and to this conveyor chute. That way, food will be frozen as soon as food enters here. Okay. Now, this food is also accessible by this auto sweeper, and job of this auto sweeper is to pick up everything that is here and put it in a spice grinder. So here right now I haven't checked up anything, but I want to create rocket spice because that is gonna be useful for us later on. So this conveyor loader is going to do that, and once that rocket spice food has been created, that rocket spice food is going to get dropped on the floor. Now here we have Sweepy. Sweepy's job is to pick up everything that is dropped on the floor, including the food that is created here, as well as whatever food duplicants just put it on the ground. So Sweepy can pick up both of those. And once Sweepy has picked up all the food, I'm going to configure here to sweep only, and everything that is edible is going to get picked up by this conveyor loader, and that is going to get pushed back onto our cooling loop. So this way it goes here, and from here it gets bridged onto the cooling loop, and it will get chilled and get stored back here. So no more useless food that is gonna be wasted just because dupes haven't checked it up or picked it up. So that is the whole system. Now to chill this system, we have liquid storage tank, and this storage tank contains 200 kilograms of petroleum at -17 degrees Celsius. Now petroleum's freezing point is well below 50 degrees Celsius, -50, so we should be okay in that terms. So what it does is, it will just take whatever petroleum that is coming here, chill it using the aqua tuner, and store it here as a temperature buffer, and it will eventually lower the temperature here. So right now temperature is going gradually down and down and down, and I'm configured this temperature sensor to go up to -30 degrees Celsius. So until and unless it reaches -30, it is not going to stop. Now we do need I'm just going to remove the priority of Sweepy. Now we do need to keep a refrigerator in the kitchen just so that we can use a spice grinder, because that is a room requirement. If I click on rooms and if I look on kitchen, yep, we need to have a cooking station, spice grinder, refrigerator, and no mess tables. That's the minimum requirement. That's fine. So we kept the refrigerator here for temporarily, and we are just going to store 10 kgs of barbecue in here, or maybe 2 kgs of barbecue. And this auto sweeper can pick up all the barbecue that is stored here and put it here. Later on, I'm just going to remove barbecue from the fridge once the deep freeze is up and running. And the deep freeze is still not up and running. You can see the chlorine gas temperature is still -14 degrees Celsius. It has to go down below -18 for a deep freeze. And right now, temperature wise, you can see this is getting chilled. We also put down some bleach stone in here because I wanted to have a sterile atmosphere that is not going to let any polluted oxygen off gas. So that's why if I click on a gas overlay, you can see chlorine is here, here, here and everywhere. So all the germs will get deleted just because of the chlorine, and once it finishes off gassing this bleach stone, we can remove it. We also put down a micro musher in anticipation of the future that we are going to make berry sludge for our duplicants while they are going on the space missions. So berry sludge is gonna be their meal of choice. And you can see barbecue has been delivered over here. Now Murray, can you access this barbecue? If I say move here, so Steve can stand here, pick up that thing and put it there. Now this barbecue will be picked up by this Sweepy. Go on, pick up Sweepy. Yep, Sweepy has picked up the barbecue. Barbecue is going to go back to Sweepy's dock, and this auto sweeper is going to take the barbecue, and barbecue is going to come here in the cooling loop and will get started to chill. Right now it's 44 degrees Celsius and is getting chilled. It is not chill enough, so it is going back in the chilling loop again till the temperature goes down, core temperature goes down. Unfortunately, I cannot make this cooling loop any bigger because I want to have this much space for a rocket to go somewhere over here. So that's why I have to keep this block very small. I'll have to retrofit something later on, but that's a problem for tomorrow. For now, I think it took a whole lot of time to make this kitchen up and running and fully functional. Temperature wise, this is going to get chilled, and this chill is going to leak a little bit into the kitchen, and that's fine because we anyways need to cool the kitchen. So might as well let the chill leak. How is my petroleum doing? My petroleum is chill status wise. Yeah, minus 30 degrees Celsius. So this should stabilize pretty much, and as soon as it goes slightly above the configured temperature range, minus 30, it will start running the aqua tuner. Right now the aqua tuner is stopped because this sensor is saying it's minus 30 and it should not do anything about it. And to stabilize this even more, I can put in a little bit more of petroleum, and as long as there is sufficient petroleum in this tank, the temperature should not deviate a lot. And the reason why I'm setting it to minus 30 is chlorine gas. So if I click on chlorine here and check on its temperature, chlorine will freeze at minus 34.6, and I don't want to do that. So that's why I want to have a perfect buffer where we are going to keep chlorine at a decent minus 30 temperature forever. We also need to break open into our natural gas geyser tamer. It seems like somehow that little bit of crude oil got deleted from here. I was trying to be, smart, over smart I guess, and not have two tires. Generally it's recommended to have two tires so that the liquid gets pushed to the other tile and get pushed back to the same tile again. So I guess we can just open it up. I just moved 2 kgs of naphtha here. We are just going to empty that naphtha. Once the naphtha is empty, we can deconstruct this tile, go in and drop some crude oil or naphtha. So Nicola has collected 3.3 kgs. That's pretty good. We'll move this. So you have 2 tiles, so 1.5 kgs per tile approximately. Started working. Great. This is what I wanted. Now just block it up so that it doesn't go anywhere, and now we have our storage up and running and working. I'm also going to do one more thing. Power wise, we are running slightly short on power because we are running on coal all the time. So I'm just going to use a natural gas generator and just put a natural gas generator somewhere over here. We have enough heat in the steam box and enough pressure in the steam box. So you can see right now we have 12 kgs of pressure. That's one option. Other option is I'll just put the natural gas generator somewhere over here and just pump out all the polluted water somewhere. We anyways need polluted water to generate a little bit of clay. So it doesn't hurt to have more polluted water. That is probably what I'm going to do. Just put a natural gas generator over here and it should start running automatically. Our temperature is rising more than I like. Right, this temperature sensor is set to 150. It's not really circling the heat that efficiently, unfortunately. That's fine. I need to put some more temp shift plates, but I'm skimping on granite because we don't have enough granite right now. Now it is cycle 202 and I think we need to start clearing out this area. I want to have a renewable source of polluted water as well as power and food. So I think some molten slicksters would work really fine in that case. So let me do one thing. I'll move all the slicksters here. They will eventually convert into molten slicksters just because of the temperature. If you see the slickster here and you check a look at their molten larva eggs, it's 2%, but it increases with the body temperature above 100 and between 250. So what I'm going to do is put a critter drop off here in our steam room, which is nice and toasty, 160 degrees Celsius around, made out of steel. We'll just move all of the slicksters in there. There's plenty of space for them. They will eventually convert into molten slicksters by the time we carve out this area. And I think I'm going to create a couple of ranches somewhere over here for molten slicksters. So give me a moment to clean up this area. We need to remove all the polluted dirt as well as the bleach stone so that it does not off gas and we can pump out all these nasty gases. So while we were cleaning this, we ran out of calories again. So you know what it is time for. A nice culling of some of our population. We should get enough meat to tidy us over a little bit, but yeah, we need a lot of meat. So after so many cycles, we finally are able to clear out this whole area. It is still being pumped out, vacuumed out, but it's fine. We can start planning our session. So what I want to do is first of all tame this minor volcano. And this minor volcano is going to go dormant pretty soon. It's going, next dormancy is 11 cycles. So before it erupts, it will go dormant. That's good. And it is a very, very small volcano. So if my calculations are correct, this minor volcano is, okay, let me take out my calculator, is emitting 126.1 kilograms of magma every 66 seconds. So 126.1 multiplied by 66, that's gonna be 8.3 tons of magma this volcano will erupt over a period of 9,641 seconds. So that equals to around 0.86 kgs of magma per second. So if we are able to store that much magma, that is 8,300 kgs, which would require us around this much divided by 1800 is around 6 tiles. So if we are able to store 6 tiles of magma, we can constantly pump 1 kg of magma per second using a liquid pump, a mini liquid pump to be precise. So what I'm thinking is, instead of building a contraption for taming this volcano or running a petroleum boiler right next to the volcano or something like that, why not just pump out the magma from this thing, store it in liquid tanks, and we can just use it anywhere we want as a heat source. So I think I'm definitely going to do that. So let me figure out a design. So plumbing wise, what we can do is we can just put a mini liquid pump. I know this is made of plastic, which has a melting point of 159.9 degrees Celsius, which is obviously way lower than the magma, which is 1700 degrees Celsius. But I think if we do it right, where we let the magma come over here, flow down, go all the way over here like a magma blade, and just keep on pumping it like this, it should not make a mess. That's my hope. I might be wrong, but we'll figure out only one way to figure out. So what I'm thinking is I'll just keep on pumping all the oxygen out of this. Mini gas pumps are already on the way. I'm going to run, let's say, obsidian tiles, because obsidian is the only thing that will not melt with magma, like this. And I will have a conductive panel over here made out of steel. I can't put it here. Give me 1 second. So cancel this, and this will be our design for magma tamer. So right now I'm just converting all of these obsidian tiles to ceramic because I had too much ceramic, so why not. But one thing I learned dealing with magma is always have a fail safe. So what I am going to do is I am going to put a steel door over here that is gonna be controlled by automation. So let's say if I put a hydro sensor made out of steel over here, and everything should be made out of steel. So what I'm going to do is just put an automation wire here, that if volume of liquid that is here, that is magma, goes above a certain level that we are unable to pump it out, it should close this door, which will prevent magma from actually getting into our plastic liquid pump and, you know, melting it out. That would be horrible. So this will be our automation over here. I'm just trying to get rid of all this nasty polluted oxygen that is over here, and unfortunately it's taking a long time. So what I did is I just put a mini gas pump over here. I'm going to seal it up with a little bit of naphtha. So let's move naphtha over here. So let's put down a cooling solution somewhere over here. I want to have a steam turbine over here that is going to generate cooling, not just for this volcano, as well as all the ranches that are there at top as well as bottom. I'm just going to put a cooling solution somewhere right over here. So let's see how it looks like. So probably a steam turbine over here. Yeah, that looks fine to me. So this is a completed system. I'm just going to finish up this liquid reservoir. But ultimately what we have is a simple piping where we are getting all the polluted water, storing it in a buffer tank. And this polluted water will go out here to chill this mini liquid pump. After chilling from the mini liquid pump, it will go through aqua tuner and come back here to get stored in the liquid tank. Now this also goes through a little bit of naphtha that I'm just going to empty here, which is going to act like a transfer medium between steam turbine and our coolant. And this whole room will be a steam room. This is protected by a little blob of naphtha. If I click on liquid, you can see here it's right here. So all the steam should ideally stay within this part, and it will not displace this naphtha if I just close it off for now. Otherwise, this power line is going to come down here and all the way here. So I thinking this is a great place to make a ranch, especially for our slicksters. And we need this ranch to produce a bunch of CO2 and consume the same CO2 while heating it up. So what I'm thinking is, let's have a CO2 consumption or CO2 production over here, where we are going to put a bunch of generators and everything. They are going to pump up CO2. That CO2 is going to come up over here, this side, get heated by this steam chamber, go down here and get consumed by all of the slicksters. So let me build the ranch and I'll show you how it looks like afterwards. And here is our ranch. So you can take a look at this ranch. This is perfectly 96 tiles, and this ranch is going to cater to all the molten slicksters. The next thing that we want to do is we want to have a CO2 production somewhere over here that can be pumped up over here. So let me figure out yet another ranch design. In this case, we want that ranch to be able to generate CO2 as well as serve some of the critters that we have. So this will be the hot area and this will be a cool area. I want to have like a mix of hot and cool. Surprisingly, we are able to get a lot of ranches here. So one ranch is this, 2, 3, 4, and a mini ranch. So yeah, we'll find a use for ranches later on. But right now the goal is to have CO2 generation here, get all the polluted water that is going to get generated using all of these generators go down. So done. So you can see this place, we'll have two blobs of gases here. Right now everything is vacuum, and once we have two blobs of gases, any liquid that falls here will go here and just get collected over here. All we need is a homogeneous type of liquid. We don't want to have a mix of petroleum or something else. So that's why I'm going to seal this part off. I'll explain this later on. This is a petroleum bead pump that will use to push all the CO2 that is going to get generated here all the way up. So as you can see, if I click on materials and the liquid, everything is liquid locked. So now nothing should get out. This is a perfect vacuum, and now we want to ruin this perfect vacuum with a bunch of CO2. And the easiest way to do that is coal generators. We don't want any side effects just yet. All we want is just CO2, and that is it. So I'm just going to put a bunch of coal generators over here. And also our volcano is up and running. So minor volcano is emitting liquid here. This liquid pump should detect liquid. Is it detecting liquid? I think this pump needs to have liquid on this tile to detect it. Yeah, that's not ideal. And what is this? Igneous rock. Somehow it got, because of this mechanized airlock. Never mind. So let's see. This automation is working. It is only keeping 100 kgs of magma over here, and once it has 100 kgs of magma, it is going to close the door. I think I need to do some testing in the background to figure out what do I need to do here. We will definitely have to open this area up and rebuild some of it, which is fine. I think that's a good stopping point for us for this episode. We created a working freezer, and for the next episode we can take a look at how to fix this geyser. So I hope you folks enjoyed this episode. Hope to see you folks next time.